Welcome everyone. Today we're going to look at graphs of motion, but only graphs of motion for vertical motion, and it's actually lots of fun. So, have you ever thought about how graphs can be useful when describing the motion of an object? We've done the equations, but sometimes the equations are difficult to imagine what's going on. When we have graphs, the graphs give us a much better picture, and we can get information from the graphs, okay? So, we've looked at, through the series so far, definitions, equations, acceleration. Today we're going to look at graphs. So our keywords are velocity, which hopefully we know what that is, displacement and position. We're going to look at acceleration due to gravity, and then of course direction. Direction, 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 direction. If there's something that's going to make you make a mistake, it's going to be direction. So we've got to be very clear on our directions, okay, because we're dealing with vectors. So when we look at the graphs, we're going to have three types of graphs. We're going to look at velocity time graphs, which are always curves. We're going to look at velocity time graphs, which are always straight lines. And then the nicest out of all of them is acceleration versus time, because the acceleration we're working with is constant. It's 9.8 meters per second squared down. So it makes that graph really, really nice, and we hope we get asked one of those. Let's look at a position time graph. We're doing sketches, so please, you really do need to use a ruler. I can't on the board. So we always have time, and we have position. Now, depending on which direction I take as positive, that's going to determine whether the graph sits above the x-axis or below the x-axis. So let's take up as positive. Okay, as we take up as positive, let's pretend that I'm throwing an object up. It's going to reach the top of its motion, and then it's going to come back down and go below where I threw it from. And where we threw it from is my zero position. So the motion is going to be this. My object starts at naught, oops, and then as it goes up, it gets slower and slower and slower and slower, and then it reaches the top of its motion. What I need you to see is that as it goes up, the gradient gets less and less steep. The gradient's getting less steep because it's slowing down. So it's covering smaller time distances in the same time period, but it's slowing down. And then it gets to the top of its motion where the displacement doesn't change, just for a fraction of a second. Now it's going to come back down. As it comes back down, it gets faster and faster and faster and faster. Now, if it goes past where it started, it'll just keep going straight. What are we looking for? Is realizing that as it goes up and it slows down, the gradient of the graph gets less steep. As it comes down and speeds up, the gradient gets more steep. This is nice because it looks like the motion of an object being thrown up. If I change down as my positive direction, still, now I've got to go below the axis, gets slower and slower and slower, so the gradient changes, gets less steep, gets to the top, and then it speeds up. Now, it's not quite the same. It should cross the same place. Doesn't matter. The gradient gets more and more steep as it gets faster, less and less steep as it gets slower. I'm not worried about whether it's a positive gradient or a negative gradient because it all depends on which direction I took as positive. It's quite nice, okay? Then we get our velocity versus time graph. And the nice thing about these is that it's always straight lines. Now, whether we start at zero or at another point with a velocity all depends on whether we threw it up, whether we dropped it, anything like that. So let's just take it as having dropped. I'm going to take down as my positive direction for the first time. And what happens is that it's a straight line. Why? Because the acceleration due to gravity is a constant. I can get acceleration from the gradient of this graph. And it's always going to be a straight line. If I take down, up is positive, all that happens here is now my graph's going to go that way, still a straight line. Gradient of the graph is acceleration, and we can find displacement by looking at the area. And lastly, if we look at the acceleration time graph, this is the nicest out of all of them, always a straight line. If we have down as my positive direction, it's just going to be that, and we know that this value is going to be 9,8. If up is my positive direction, then this is minus 9,8. It's a constant. Makes our lives very, very easy. So, when we look at the graphs, okay, we've got velocity time, displacement time, position time, acceleration time. Shapes are the same. We just need to be able to put them into different contexts. Right. We're going to take a short break, and I'll see you in a couple of minutes.